Obviously didn't bother.
No. Looks like you used it to motivate you.
Same here.
Okay, let's do number 1 on lesson 8.3. There's 5 steps you got to follow, all right? And you don't really have to memorize these, but you'll probably do it so much you will have it memorized. But on the test, it'll have these 5 steps written out for you. State the hypothesis and identify the claim. That's step A. Step B, find the critical values. In this case, those will be z-scores. Compute the test value. That's going to be a z-value also. Step D, make the decision to you're either going to say reject the null or do not reject the null. And then step E, you have to summarize the results about the claim. You're going to talk about the claim. So here's number 1. Says use diagrams to show the critical region and use the traditional method of hypothesis testing unless otherwise specified. So these 5 steps are what's called the traditional method. Tomorrow we'll learn about a different method, but for today let's focus on the traditional method. A survey claims that the average cost of a hotel room in Atlanta is $69.21. To test the claim, a researcher selects a sample of 30 hotel rooms, finds the average cost is $68.43. The standard deviation of the population is $3.72. At alpha equal 0.05, that's the level of significance, is there enough evidence to reject the claim? So the claim is that the average hotel costs $69.21. So what they're claiming here, and first we're going to write our null and our alternative hypothesis. So you write H sub 0, which stands for null hypothesis, make a colon. Same thing with H sub 1, that's the alternative hypothesis. Then we're talking about the average cost of hotel rooms. So we're going to use mu to represent the average cost of all hotel rooms in Atlanta. The claim is that the average is or equals $69.21. So they're not really saying greater than or less than, they're saying equal. $69.21. Now, one of these has to be an equal and one has to be a not equal to. You guys remember which one always has to be equal? Right, the top line, the null hypothesis always has to have an equal, greater than or equal to, or less than or equal to. So that's going to be an equal. So down here, this will be a not equal to. For a label, let's just put a $sign on it.
What if you have like a greater than or less than equal to, then what is the alternative?
Like if this is greater than or equal to, this would be less than. If this is less than or equal to, this would be greater than. They're just like they're opposites. Okay? And now you got to also put down which one's the claim. Are they claiming that it's not equal to 69.21, or are they claiming that it is equal to 69.21? Claiming that it is equal to 69.21. So you're going to put the word claim up here in parentheses. It could be either one. I mean, you could claim that it was or wasn't equal to 69.21. But in this case, the researcher's claiming that it's 69.21. Next, we're going to find the critical values. The critical values are z-scores. Okay, so I'm going to draw a picture here. I do want you to draw a picture for this. Alpha is 0.05. Now, the next thing I have to decide, is this a one-tailed test or a two-tailed test?
2.
Right. If you have an equal and a not equal to, that's a two-tailed test. So, because it's not telling us if they think that it's not telling us if the average price might be less than that or more than that. So we're going to look on both sides. We're going to look above and below, or to the right side and the left side. When that happens, when it's two-tailed, which is because of the equal sign up here, you have to divide alpha by 2. So alpha divided by 2 is 0.05 divided by 2. 0.025. So that's this area here, and also this area over here. But what I really want to get is this area right there. How would I get that? 0.5 minus 0.025, 0.475. So then you go to your z-chart. You go out in the middle and try to find 0.4750. If you can't find it, you find the number that's closest to it. If it's exactly in between two numbers, then you go up to the higher number. Anyone tell me what the z-score?
1.96.
1.96. And you might recognize that number from when we did 95% confidence intervals, because if you have 5% in the tails, that means there's going to be 95% out in the middle, and 95% of the data is within 2 standard deviations of the mean. Remember that from the empirical rule? But to be more exact, it's not 2, it's 1.96 standard deviations from the mean. So our critical values, which in this case are z-scores, are values that you look up on the z-chart in this case. So our critical values are z equal negative 1.96 and positive 1.96. Any questions about that? Third step, compute the test value. The test value is going to be found using a formula. It's a formula you've seen before for z-scores. It's x bar minus mu over sigma divided by the square root of n. X bar is the sample mean, mu is the population mean, sigma is the population standard deviation, n is the sample size. So sample mean should have been given in the problem. It says, the researcher selects a sample of 30 hotel rooms. What letter is the 30 going for? N. Yep, that's the sample size. Finds the average cost is $68.43. So the sample average, or x bar, is $68.43. The mu will come from the claim, claiming that mu is 69.21. So we don't know for sure that that's what it is, but that's the claim. So we put in 69.21 here. Standard deviation is given in the problem. 3.72, $3.72. And then divided by the square root of 30. Now, if you're going to type it in all at once, you need to make sure you have parentheses here and here. And you probably have a set around the 30 too. Type that all in, it should give you a z-score.
Negative 1.15.
Negative 1.15.
Yeah.
Anyone else get that?
Yeah.
Okay. Must be right then, right? So negative 1.15. So let's think about where is that at on our picture down here. If it falls in the tail area, in the critical region, then we're going to reject the null. If it doesn't fall in the tail area, if it falls out here, then it's going to be do not reject the null. So if anytime it falls in the tail, it's reject. Anytime it doesn't, it's do not reject. So 1.15 would be, here's 0 in the middle, right, on the standard normal distribution. Negative 1.15 would be about right in there, approximately. It'd be somewhere in the white region. So the white region is the do not reject region. So based on this is our test value. Our test value falls in the non-critical region. So you say do not reject the null for step D. Do not reject the null. Now you might be thinking, well, hold it. The null says that the mean is 69.21, but our sample was 68.43. They're not the same. So wouldn't it seem like we should reject this? But really, pretty much anytime you go out and do a sample, you're not going to get exactly 69.21, are you? The fact that we're going to get a different answer is due to something we had on a previous test. Anyone remember what that's called? That when you take a sample, you get a different answer than the population mean? Sampling error. Yeah, you're going to have sampling error. So the question is 68.43 close enough to 69.21 that we could consider them equal because of sampling error? If your value falls anywhere in this white area, that means you're close enough, right? If this was 69.21 minus 69.21, what would this come out to?
0.
Right, 0. If our sample mean matches our mu exactly, then we're going to be at 0, right here in the middle. So the fact that we ended up a little bit left of 0, that just tells me that 68.43 is a little bit less than 69.21. If the score would end up down here, that would have said that it's far. If you end up in the critical region down here, that would mean that the sample mean is too far below the population mean, so then you would have to reject the null. If your test value ends up here, that would mean that your sample mean is too far above your population mean. So then you'd have to reject the null. But anytime it's in the white area, you say do not reject the null. Any questions about that? Now, summarize the results about the claim. So now we're going to talk about the claim. If we do not reject the null, and the claim is the null, now we say do not reject the claim. So we're going to say do not reject the claim that, and then I want you to state what the claim is, that the average hotel room in Atlanta costs $69.21. Do not reject the claim that the average hotel room in Atlanta costs $69.21. Now, have we proven that it is $69.21?
No.
No, we haven't proven that. We just don't have enough evidence. And actually, that's probably the better way to say it. I'm going to reword this. This is the proper way to say it. There's not enough evidence to reject the claim. Sorry, I'm changing this. Evidence to reject the claim that the average hotel room in Atlanta costs $69.21. It's kind of like when you try to catch a criminal. Just because you don't convict them doesn't mean they're not guilty, it's that you don't have enough evidence to convict them. It's kind of like that's what's going on here too. There's not enough evidence to reject the claim. Any questions about that?